Okay, so today I want to start into this section here. Again, I'm not going to cover all the slides, I don't think. Now, some of you may have noticed that I've put a submission link up on Moodle. The way this is going to work is if I just click into this week's lab, and straight away you can see at the top, I'm telling you that this lab contributes to your CA. It's not so much this lab, but there's actually going to be a series of 4 labs over the next 4 weeks, where in the series of labs, you are going to be incrementally building a React app. And we really give you each step along the way. It's very prescriptive. And then you will be submitting that work at the end of the 4 weeks, and it will contribute about 10 or so percent to your CA. Now, on Moodle, I'm saying there's a submission and the deadline is this Friday. What you've got to submit by this Friday is quite simply the URL of a GitHub repo that I asked you to create. If I go on to the next page in this lab, and if I scroll down a bit, I explain here what you've got to do. Ouch, sorry. Where did that go? Let's try that again. Explain here what you need to do. And essentially I'm saying create a GitHub repo, give it a specific name, and then send me on the URL of that repo. Put the name into a text file and upload that text file to Moodle, and that's it really. So that's pretty straightforward in terms of what you've got to do. Then each week, including this week, you will be pushing code to that repo. And as I said, at the end of the 4 weeks, you'll have a fully functional React app. So are there any questions about that, I wonder? It's very straightforward, I hope. No?
Nope.
Great. Let's start the lecture in that case. I don't know if you're hearing the humming sound going on in the background here on my side. Fortunately, there's some, I guess it's air conditioning, but it's incredibly loud and I can't turn it off. So I hope it's not interfering too much. Right, so I'm going to start into these slides here. And there's an important archive with not only this week's lecture, but this, or not this lecture, but it'll go into the next lecture as well. So it's the usual story with the archive: download, unzip it, and import it into VS Code, etc., etc. Now, last week we were developing React components, but one characteristic of them, we would say, is that they were static. User couldn't interact with the component, and the component didn't change based on a user interaction. So hence they were static as opposed to dynamic. We're going to change that this week though. So I'm looking a little bit deeper into the whole component model part of React. And in particular, we want to look at something called component state. And it's this notion of state, or this concept of state, that is what's going to be central to making our components dynamic based on user interaction. Then I'm going to talk a little bit about data flow within a React app. What I did say last week is that any React app you ever develop is going to be a hierarchy of components. And it turns out that data can flow between those components only in one particular direction. That was a conscious decision made by the React design team for various reasons. And thirdly, then we want to talk about something called hooks, which is it's part of the React programming model, I suppose. Let's just leave it at that. It's a very important part of the programming model, though. and it was only introduced in 2019. React has been around since roughly 2013, but they made a fairly significant change to the programming model in 2019, which was in alignment with React version 16, I think. But first of all, I want to talk about component state. And state is related to the data part of a component. Now, what we know so far about a component in terms of its data is that data can be passed into a component in the form of props. And what we know about props is that they're passed into a component, usually by a component's parent component. That's the only way, really. A component receives props from its parent component. The second thing we know is that props are immutable. And thirdly, props come in the form of an object. That's how they're passed in. Now, the second aspect of a component's data, though, is what's called state. And state is kind of everything that props isn't. State is something that is state is data that is managed internally by the component. Secondly, it is mutable, and whenever you mutate or change a component's state data, then that component actually re-executes and potentially changes what it displays. So it's what makes the component dynamic, as we'll see. Right, so whether it be props or state, though, you can use any kind of data type for either of them. So it could be a primitive, it could be an object, an array. So it's very flexible. But our focus from here on in now is in this lecture anyway, is going to be on state. Props are still very important, but we want to look at this notion of state. And it's, as I said, it's this state data part of a component is what will allow us to make a component dynamic. Before I move away from props, though, quite often you may be using a component that you didn't develop. It's a third-party component, or somebody else in the team developed a component that you're using. And, it may have a number of props that you are allowed to pass to the component. But what if you, by accident or by purposefully, you don't pass certain props into a component? Is the component just going to die as a result? It would be nice if a component could have default values for props, just in case it doesn't receive them from whoever uses the component. So how do we declare default values for props? I'll show you how to do that. The other thing, which is really more a consequence of the fact that we're writing our code in JavaScript, is it would be nice if our component could check that the data that's passed in for a particular prop is of the right type. So it does some sort of type checking. Now, I'll be honest, a lot of React code, most React code that I read, and in fact, React code that I might write myself or that I will show you throughout this part of the module, I don't use this aspect of props, but I am making you aware of it. Okay. Going back to state, though, in terms of state, there are two things that we need to know how to do. A, how do you initialize a state variable? Because state variables now aren't going to be just ordinary variables that we declare using the let and const terms or keywords. There'll be a little bit more than that because of the role they play. So how do we initialize them? And secondly, then, how do we change their values or mutate them? Equally, because they're special variables, we can't just mutate them by reassigning using an ordinary assignment statement. That won't work either. So our one-on-one example is going to be what I'm showing you here on the right is, let's suppose we've got this simple counter component. And what I'm trying to get across here now is that the component expects a prop, which I'm going to call jump, and the prop is going to be an integer. And this is my way of representing the internal state data of this component. It's also going to be an integer, coincidentally, and I've just got to call it count, and its initial value will be 0. And my component is also going to have a button, and the idea is every time the user clicks the button, we want to change the count state variable incremented by whatever value jump is. Okay, so it's just bumping it up incrementally. Now, this little counter example component was actually available to you in the basic React lab from last week. It's sample 6, it says there. So if I go back to, do I want to go back to it now? Yeah, I do. Let's look at the component now. So it's this one here. Maybe if I show you what it does first. It's not terribly exciting, but anyway. So here's my component, and every time I click my button, you can see that this value here is changing. But even though it's very simple, it is a dynamic component. The component is changing what it shows on the screen. Okay, all it's changing is this part here, but that's sufficient. So let's look at the code for that component. And so in terms of state, the key line, one of the key lines is this one here. This is how I declare a state variable. So there's a special function called useState, which you can see here I'm importing from the React library. And the useState function, what you pass it is the initial value. Sorry, here. Sorry, what am I? Yeah, useState. What you pass it is the initial value for the state variable. So because I'm passing it 0, means that my state variable is of integer type. What it returns then is a 2-element array. The first element in the array is going to be the current value of that state variable. So initially that's going to be 0 because of what I said over here. The second entry in the array is actually a function, and it's that function that we use to change the value of the state variable. Essentially, the function is a setter method. You might remember setter and getter methods from your programming. That's essentially what the role of the function is. It's a setter method. You can call this method anything you want to. You can call this anything you want to. But by convention, the method is called set something, where the something corresponds to the name of the variable. So that single line is declaring a state variable of type integer for this component. The rest of the, if I just skip this bit here, here's what the component renders onto the screen. And that's consistent with what I showed you a moment ago. So it is rendering as part of its output. It's rendering the, where does it come? Yeah, it's rendering the current value of the state variable. It's also rendering the prop that has been passed in. That doesn't change though, but this value here is changing. We also have our button, and the button has an on-click handler. And if we look at the on-click handler, it's just a function, obviously, but the on-click handler is calling the function that allows me to change the state variable. So I'm just passing it the current value of the state variable, and I'm adding the jump value to it. And I want to set my state variable to that new value. Now, the key thing though is that every time you invoke a state variable's setter method, what actually happens behind the scenes is not only are we changing the value of the state variable, but the entire component re-executes from beginning to end. What we say is that the component re-renders. And it's because by calling the setter method that the component re-renders, that's what allows a component to potentially change what it displays on the screen. In our case, all that's changing from one re-rendering or one re-execution of the component to the next is this value here is changing. That's fine. It's something anyway that is changing. So again, the key thing is, this is how you declare a state variable. You need to understand what it returns. And you need to understand what the role of the setter method is. A, it changes the value of the state variable, but critically, B, it causes the component to re-render or re-execute itself. Just to prove that it is actually the entire component code that re-executes. It's not so much that it just kind of re-executes this part. It re-executes the entire function, because our component is anything other than a function. I've put a console.log in here, right? And if I open up the developer tools in my browser, I'm just going to do a manual refresh first. And if I open my developer tools, as I keep clicking the button, you can see what's happening over here. And this is coming from the console.log. So I think I wanted to output the current value of the state variable and the prop value, I guess. Yeah. Now I haven't shown you what prop is passed into it yet, but that'll come in the story. That's actually written in the story. So every time I click the button, my entire component re-executes. That's what we call re-rendering in React terminology. Now the story, stories that are just controlling this, because I am running it within Storybook. We just quickly look at them. Now there's actually one error in the code that I gave you, and if I correct it, or is there React default normal? Maybe there isn't. Just check that again. Oh, sorry, there is. Yeah, here. An error there, that should be exceptional. Now I've decided to you have 3 stories, mainly to demo aspects of props rather than state. You have the essential now of what I mean by state and how that is programmed. But if I go back to the actual component, there's a little bit of code down here. This is the code that affects the props side of things. I said there in the slides that how can we declare a default value for a prop, and how can we somehow declare what type the prop should be? Well, the coding now is quite ugly, but this is how you declare the default value for a prop. We know that the prop is going to be called jump. And essentially what I'm saying here is that the default value should be 2 if this particular component happens to be invoked without any prop passed into it. This coding here is expressing what type the prop should be. What we're using actually is a third-party library called, is it there? Yeah, it's a third-party library that it's quite an expressive library when you get into it. We won't be using it, to be quite honest, but again, you could kind of work out what is being expressed here, in that we're saying that the jump prop should be a number, a primitive number. Now, going back to my stories. So in this story, you can see I'm not passing, in this story here, I'm not passing any jump prop. So based on my coding, it should default, the jump prop should default to 2. This is the normal kind of case where I'm being explicit about what prop value I want to pass down to my component. Here is where the kind of type checking will kick in. I'm setting jump to be a string, and that's going to conflict with what I said the type of prop should be, which, we said it should be, where am I going? Oh yeah, we said it should be of type number. So I have 3 stories, and we've just tested the normal one, the default one, sorry. So the prop here is coming in as 2. In the normal story, I set my prop explicitly to 3, so it should be bumping up by 3 every time. In the third case, where the prop is a string, the reaction now is not what you'd expect. What actually happens is this. Okay, it's actually just doing string concatenation. The type checking that React performs, it's not so much that it throws an error back to the user. What you need to do is look at the console. It'll actually put an error into the console. It's more for the developer than the user. And if I just do a manual refresh here now, just clean up the right-hand side. Is it telling me that there? I think it's telling me here. Yeah, it's just giving me a warning message here saying, look, you're using the component incorrectly. So it's, as I said, it's more for the developer than the end user, which makes sense because end users aren't going to know about props and state and all this sort of stuff. The key part that I want to get, the message that I want to get though, is relates to state. So it's this special function called useState that allows us to declare a state variable. It returns a setter method that allows us to mutate that state variable, as well as returning the current value of the state variable. And that function there, the useState function, it's technically referred to as a React hook. And there are a number of other React hooks as well that we'll be looking at as we work our way through this part of the module. Okay, no need to worry about that. So that's the 101 of this notion of state part of a component. Now, just to go off on a slight tangent for a second, in one slide talking about React, the React events system, we know that the browser, we said there a few lectures ago, is an event-driven environment. And for example, as the user interacts with the screen, there are events being fired, as we say, within the browser, and then you can write event handlers associated with those events. And we saw that in the counter component. The clicking of the button caused an event to occur within the browser, and we wrote a simple little event handler for it. But the names given to the various events within the browser, they can kind of be can vary from vendor to vendor, and obviously you don't want your React app to be, or you would like your React app to execute in every browser environment. It shouldn't be somehow conditional on one environment. And so for that reason, what the React team did is it catches the React engine itself, catches the event that happens within the browser, and it wraps it in a React generic event and the React generic event is called the synthetic event, right? And it's these synthetic events, that's what you write your code against. Now, if you've done any browser-based event handling programming before you heard about React, it's probably unlikely, I suppose, but some of you may have, then there's a slightly different naming convention for the native browser events and the React events. So for example, the native browser event for the clicking is called onClick or lowercase, whereas the React name is onClick using camel case. So it's these ones that we're interested in. I'm just including this slide for completeness, really. It's unlikely that anybody would have done any native event handling programming prior to this module. Back to this whole area of state, though, and how it, what its impact is. So now we have, what I'm showing you here is kind of the flow that happens within our little contra component. So the user clicks the button. Clicking of the button triggers the execution of my onClick event handler. My onClick event handler changed the component state by calling the setter method. And then the next thing that happens, which is really where the React framework takes over, the React framework then takes care of re-executing the component function from beginning to end, which is what we call re-rendering. Okay, that's the 101 of component state, but we're going to have state all over our apps. And so, you know, we're only going to have more state, but the fundamentals don't change, obviously. Next thing I want to talk about is data flow patterns within a React app. Now, there are a couple of messages that I want to get across from this diagram. What I'm showing on the diagram is a generic React component design, let's say. And so the idea I'm getting across is that the design of my React component, I have a component at the design of my React app, I've got a component and it has two child components. This child component has one child, that child has another child, and so on over here. So this is my component hierarchy. Now, what exactly do I mean by this relationship here? You know, I'm saying that this component has two child components. Well, we've actually seen it already. If I go back to VS Code, and if I look at this component, so here's the full component. Drop that there. Here's the full component. But if we look within its JSX, we see that it's actually using another component as part of its JSX. In fact, it's using two of them. It's using that one and that one. So I would say that this component, which I've just called demo, it has two children, this one and this one. And potentially, if we looked at the code associated with that component, it may have children as well. So it's that parent-child relationship. That's what I am representing by this connecting line here. It's got nothing to do with inheritance or anything like that. That's point number one. Point number two is that a component can pass data or props down to its children. And so, but these props can only flow in a downward direction. Hence, which is kind of the whole, the heading of this slide, data flow within a React app is unidirectional, as in props can only pass in a downward direction from parent to child. The next thing I want to get across is I'm just using a color coding scheme here, which is components that are kind of backlit in this browny orangey color or kind of pinky color. I'm not sure what color it is. That is meant to represent a stateful component. So somewhere within this component's code, it has a state variable or variables. Whereas the ones that are just plain white, they are stateless. They don't have any state variables. So it looks like I have two components within my hierarchy that are stateful and the rest are stateless. And that's typical of any React app. The majority of your components are going to be stateless. A small number will be stateful. Now, how we come up with which ones should be stateful and stateless, that's for another day. Let's just understand the diagram as we see it. The next point is, so this component is stateful. And we know now that if the component's state variable changes value, then we said this component re-executes or re-renders. That's still the case. But because it has two child components, it means that whenever this component re-renders or re-executes, these two are going to re-render as well. And whenever this one re-renders, these two are going to re-render. And so on down along the left-hand side. So whenever the top component, which happens to be stateful in this case, whenever that re-renders, the entire hierarchy of components re-render or re-execute themselves. That may seem inefficient, but there are ways that React can improve on the efficiency of that fact. The other thing, I suppose, is that if we stick with this component here, when its state changes and it re-renders, the props that it passes down to these may actually change because maybe it recomputes them. So it's getting new. This one might be getting new props each time it's invoked by its parent. The next point is there may be occasions when this component's state changes and it re-renders, but based on some computation that the component does, it decides, I don't want, let's say, this component to be included in what appears on the screen. And so if that isn't going to be included, then these two aren't either. So based on some user interaction and some computation that this component does as a result, on occasions, this entire part of the hierarchy may be inactive, let's say. Then later on, the user interacts again with this component, and the computation done by it may mean that this side of the hierarchy becomes active again. Now, we don't talk about active and inactive in React terms. What we talk about is components mounting and unmounting from the DOM. Remember the DOM, this data structure that the browser maintains? Each of these components contribute something to the DOM, potentially. In other words, they're contributing some nodes to the DOM data structure. And if a component is inactive or disabled, based on some computation done here, that means that whatever nodes that component contributes to the DOM, those nodes are now removed from the DOM. And equally, these ones, their nodes are removed from the DOM. And we know that whenever the DOM is manipulated, then the browser takes care of the rest. It'll take care of deciding what's painted on the screen or not. So let's say these three components are inactive. What we say in React is that they are unmounted from the DOM, and therefore whatever they contribute to the DOM is no longer appearing on the screen. Later on, the user interacts with this component again, causes a state change, some computation done within the component. Now it decides, I want these components to be remounted or reattached to the DOM, and they are reattached to the DOM, and the DOM now paints on the screen whatever these contribute to the web page. So that's really what the impact of state changes. It's not just that the component itself re-renders, but any child components that it have may be affected as well. The effect might be, okay, it gets new prop values, or it might be that the component, one of the child components, may not be active anymore. In other words, we say it's unmounted from the DOM. So all of that kind of activity is going on behind the scenes in a React app. And of course, all I'm really describing here is, we're making our page dynamic based on user interaction. Similarly, this component here is stateful as well. Now, if as a result of user interaction, it causes this component state to change, and it does its re-rendering, it won't have any effect on what's above it in the hierarchy. So it won't have any effect on what's going on over here. All it can affect is this child down here. So it's one picture, but there's a lot of messages that I want to get across from that diagram. Both unidirectional data flow, this notion of components mounting and unmounting from the DOM. And I'm kind of documenting them here on this slide, which you can read through yourselves. I've essentially kind of talked my way through it. And the only point I will make in addition is that, you know, your typical React app, as you will see later on as we walk our way through this, your typical React app has a small number of stateful components, but a much larger number of stateless components. Okay. And as well, I suppose the point, the unidirectional data flow. So we were talking about data flow amongst other things. And for now, we know that data only flows in a downward direction in our hierarchy through the medium of props. So we can park data flow for now. We'll come back to it though. The next thing I want to talk about are these things called hooks. So hooks is part of the React programming model. And as I mentioned at the beginning of the lecture, they were introduced in version 16.8 of the framework, which is around February 2019. So they've been around for 3 years now, but for a number of years, they weren't part of the framework at all. And what are hooks? Well, technically, a hook is just a function that's provided by the React framework. A lot of them are higher order functions, which means they either take a function as an argument or return a function as a return value. In fact, we've seen one hook already, which is the useState function. The useState we would refer to as a hook, and we know what its role is, and it did actually return a function to us, a setter method. And number two there is, I'm saying that these hooks, they allow us to manipulate the state part of a component and also to manage the component's life cycle. I'll talk about life cycle a little bit later on. So there are a number of these hooks, and we've seen one already, as I said, useState. The other really important one is useEffect, and there's a number of other ones as well. We look at about 5, I'd say, in this course, but oh gosh, I don't know how many there are at this stage. There's 20, 30 probably. And there are many, many other third-party hooks that were developed by the open source community. So they really are an important part of the React programming model. All of the hooks, their names begin with the prefix use, and that serves a purpose. I'm not sure if you've ever heard of linting in relation to JavaScript. A linter is a tool. This has got nothing to do with React now, but it is a JavaScript thing. A linter is a tool that will examine your JavaScript code for potential errors in your code. Now, turns out that in relation to hooks, there are only certain ways that you're supposed to use or can indeed use these hooks. And the React team provided some rules that you can add on to your linting tool, which will check to make sure that you are using hooks properly. And the way the linting rules work is they essentially scan down through your code, looking for any function that begins with USE as its name, and then it knows, okay, this is some sort of React hook, and then it'll check to see, are you using it correctly? Now, by using it correctly, I mean this. You can only call a React hook, I'm saying, from within the top level of a component. By top level, I mean, for example, you cannot call a React hook from within an if statement or a case switch statement or from within a for loop. You can't nest them. You cannot nest them inside there. So they can only be invoked at the outer level of a component's code. And that was the case in the counter component, if you saw there a few moments ago. So now, and of course, well, okay, the second rule is obviously these hooks only make sense in the context of a function that represents a React component, but that kind of goes without saying. The really important one is this one here. So if you start invoking any one of these hooks, let's say from within the body of an if statement, you'll get an error at the kind of compile at the source level rather than at the runtime. It'll tell you straight away. And it's the linter that's doing that for you. You don't have to install the linters, they kind of come part. Certainly within VS Code, there's a linting going on behind the scenes. So there's no extra configuration that you have to do. Now, the second most important hook is one called useEffect. And you might remember, or maybe not, when I was talking about JavaScript, I was talking about side effects. And if we talk about a JavaScript function having a side effect, you might remember I said that a side effect is when a function tries to manipulate or change data that's outside of its own scope. So that's where the useEffect kind of has the same meaning. So a useEffect hook is a hook that tries to either access data or manipulate data or other stuff outside of the component's own scope. There are very obvious examples of this, and this is where we will come across the need to use this useEffect hook. Whenever we want our React app to talk to a web API, which is running on a remote server, then clearly that would be, you know, that's trying to access data outside of its scope. So we can't just put a fetch call buried inside our component code in the normal way. We've got to actually put it inside this useEffect hook some way. Another example, which we will see as well actually in a sample application that I'll show you, is when we try and either access some part of the browser that's outside of a component, or if we want the React app to subscribe to a browser event, like window resizing. Maybe when you resize the window, resize the window, maybe you want your components to render slightly differently. So they're reacting to an event that's happening outside of the component, if you like. Hence, it's an effect that's happening from outside its scope. Now, this useEffect hook, in terms of its signature, you pass it a callback, which we know to be a function, and you also pass it what's called a dependency array, which I'll explain in a minute. Now, it's this callback that you pass to it. That's where you put the code that's carrying out the actual side effect. So, for example, if you've got a component that wants to communicate with a web API, then that code goes into this callback. Yeah, okay. And the next thing then is, when exactly is this useEffect hook invoked? Because it is just a function at the end of the day. So when is it called, or who calls it? And it turns out now that it's the React runtime that actually calls it on your behalf. It appears within your component code, but the React runtime engine knows what to do with it, if you like. And I'm saying that the useEffect function call within your component, it's always executed when that component is mounted. Remember, I talked about a component mounting and unmounting from the DOM. So whenever a component is mounted onto the DOM, then you're guaranteed that the useEffect hook will be invoked, which means the callback will be invoked. Secondly, every time the component re-renders, provided, this is the key thing though, provided one of the entries in this array has changed since the last re-rendering. So that brings me back to this dependency array. The dependency array would be an array of references to typically other variables within the component. That could be props, or it could be something that's computed, local variable that's computed by the component. So the array will contain references to variables. Usually it's just one, or maybe even none, but it has references to variables. And when a component re-renders, not on mount time now, but when it re-renders, what React will do is it'll check the variables in this array. It'll check to see, have they changed the value, any one of them changed the value since the previous re-rendering. So it must keep a history of the values. And if any one of them has changed value, then it will invoke the callback again. None of them have changed value, it skips it. Okay, so there are the rules guiding when exactly is the use effect relevant or not. Down here, I'm just saying that if all you want is for the use effect to be relevant at mount time and not on any kind of re-renderings, then what you do is you just use an empty dependency array. You can't leave it out completely, but just give it an empty array. And we'll see that a lot actually in our code. Okay, that's just talk. Let's see an example of it. Here's a sample app. Now you'll get this app with this week's archive. And what the app does is it talks to the random user web API. It grabs, I'm not sure, is it 10 or 20 user profiles. Then there's a little text, which are mostly my friends, right? Then there's a text box. And as you type into the text box, it will filter this list. Okay, so that's the app. Now, this is the design of the app. And don't worry about how did you come up with that design. For now, just understand the design. So there's just three components, and it's a nice linear hierarchy between them. This component at the bottom here, it's going to be responsible for displaying or rendering one friend. This component here is going to manage the display of all of the friends. And clearly, you know, it's kind of managing the friend component, and what it's going to be passing down to a friend component are the details about a particular friend. So really at runtime, there are going to be a number of instances of this friend component, one for each friend entry on my list. So that this component in the middle kind of manages the display of the list of friends. And the component at the top then takes care of the text box and takes care of just the heading. But critically, the component at the top, it's stateful and the other two are stateless. And the state in this case comprises of two parts, which I'm saying down here. One part of the state is the full list of friends that have been returned by the web API. And the second part of the state is what's the current contents of the text box. Because every time the user types something into the text box, this component needs to recompute the list of matching friends based on what's entered on the text box. And it recomputes the list of matching friends, and that's what it passes down to this component. So every time you type something into the text box, it has to recompute that list of matching friends, and it passes a new updated array potentially down to this component. What this component does then is it just goes through that array of matching friends and, you know, invokes one instance of a friend component for each matching friend. Okay, let's look at the code. So, I know I've already said it, but you go to this, download it and unzip it. Now, when you unzip it, you will get this, and if we go into it, there are actually two apps. Okay, we look at the second app next week. First app is what we're looking at this week. And you run npm install as usual because it's a Node project. So run npm install, and then I can do npm start. It's also an app that was created with the Create React App tool. So if I go npm start, and as I type into the text box, you know, my list of friends get filtered to that way. And you can type as many characters as you want to, though obviously there won't be matches for if you type too much. So let's look at the code. And we have the architecture, okay, on the top left there. So if I take the component at the bottom of the hierarchy, that's the simplest one. It's passed in an object that contains the user's profile, okay? And you've got a vague memory of the objects that are returned by the random user. I am using the random user web API. I think I mentioned that anyway. So, and we know that returns an array of user profiles. That's essentially what the prop for this component is going to be. It's going to be one user profile. And it's just displaying that on the screen. Okay, so there's no state here. This is a stateless component. And really, I don't need to explain that code, hopefully. If we move up the hierarchy to the middle component, what that receives as a prop is an array of user profiles. And what am I doing? I'm mapping over that array of profiles. And I'm producing a friend component for each one. So we saw this kind of pattern last week. So hopefully there are no surprises there either in that code. The tricky component is this one here. This is the one at the top of my hierarchy. It has two state variables. This one is managing the contents of the text box, which is empty, an empty string initially. This one is going to have the array of user profiles returned by the web API, and a sensible initial value for that would be an empty array, which is what I'm giving it here. I'm going to skip over the use effect for a moment. Here's the JSX for that component, the header at the top, and I'm using, here's my text box, and I'm using the filtered, what's called the filtered friends list component. That's the one in the middle of my hierarchy. And I'm passing down to it an array of user profiles. Now, here's the use effect hook. Here's the callback. And we're just using the fetch, which we've seen before. Okay, so there's no surprises there. Critically, inside in the fetch, notice what I'm doing here. I'm calling the setter method that changes this state variable here. Because at this stage now, within this code here, you know, I have the array of objects returned by the random user web API, which is going to be sorry, this expression here. That's going to be my array of friends, and I'm using that to set my state variable. Okay. Also within this component, I am computing my list of matching friends. And what it's doing is it's going through the full list of friends, which is, sorry, I beg your pardon. I should have shown you this code here. This is where I'm computing my matching list of friends. All I'm doing is I'm taking the full list of friends that corresponds to this state variable here and filtering over it. And the filtering is based on the contents of the text box. I'm using the text box here to determine whether the friend should be part of this list or not. And it's this list that I pass down to my filtered friends component, filtered friends list component. So, okay, that just computes the list of matching friends. All that's left now here is this function. And it's this function that is invoked every time the user types something into the text box, because I've got an onChange event listener associated with my text box. And so what happens is every time the user types a character into the text box, this guy executes. Now, don't worry about this line of code here. That's just some default boilerplate event handling related stuff. It has no real bearing. In fact, if I took it out, it's not going to affect anything. And just to prove that, hopefully I don't live to rue that now, but it's not going to really affect anything in this case. My app is still going to work fine. You know, it still works fine without it. So it's, as I said, it's just boilerplate. The critical line though is, from a state point of view, it's actually also changing a state variable, which is the first state variable. The first state variable is the one that holds the contents of the text box, this one here. So obviously you need to study that because there's a lot going on there. But if I go back to the slides, and my time is up, okay. Right, I'm going to halt it there, obviously. I'm kind of out of time, but that's fine. I'm going to leave it at that for now and pick it up the next day, if you're still there. Right, some of you are still there. That's fine. I'll talk to you on Wednesday. Bye for now.